Testing, testing. All right. Good afternoon. Good afternoon. Good evening. Good morning, wherever you are. Um, okay, so we're back. Um, what are we doing this afternoon? I forgot. What did we have on the list? We had data structures. We had lists and arrays. All right, but that's going to be fast to cover. I wonder what else can we do this afternoon. How's everyone doing? Monique, Leonardo, good afternoon. Good to see you. Um, we have arrays. We can do. We have arrays. We have lists in. Mm-hmm. And what else can we do? I mean, maybe that's enough for this afternoon. Hey, Andres, good afternoon. Um, Maybe that's enough for today because it's been a long. Oh, enumerators. Can we do enumerators? How could we relate that to what we've been talking about? Um, hey, Dasco, Fernando, good afternoon. Um, I wonder how can we relate enumerators to what we've been watching, doing so far? Uh, and what would be a good example to think about enums? I think I may need to give that some thought. I'm not sure if I'm ready to jump on an example for that as. Hmm. Mm, um, all right, maybe we can open it up to the chat. So, good afternoon, everyone. As you may know, we're recording things for the learning. We're recording episodes sections for the Learning C# playlist. And today my agenda was to do arrays and to do lists, so collections of data. Okay. And I think for in the next few streams, I would like to do classes, so object-oriented programming, and a bunch of examples of that. And I need to cover functions as well. But that's going to take me some time, and I want to prepare that better. So, is there any small topic, any subtopic within the world of C# that I could record an episode, like a small section for today, like a 10-minute video? Have you ever run into a problem, a particular structure, a data type, and something that is bothering you and that I could write, that I could record about? Just let me know on the chat. I'll keep an eye for that. I'm going to record a video for enums at some point. And structs. Is there Thank you. Thank you, Andres. It's great to have seen you. Have been seeing you in all the episodes so far. All right. Okay. Perhaps we could also take it easy today because I this is really cool. I just bought a new desktop computer. Like I bought a tower and a motherboard and a lot of stuff, and it's been sitting here in my office for 2 weeks because I haven't had the time to put it together. So maybe I can just record these two videos, do a little bit of social and Q&A, and then I can treat myself this Saturday evening to like a nerdy afternoon of assembling my computer because I bought everything in parts. So um, I can probably do that. Because I'm looking here at collections of data and everything else, so hash tables and dictionaries and stuff, I think it's a bit more advanced than what I would like to touch upon at this particular moment. So, so I think I'm just gonna do that. I'm going to record lists and arrays, and that's what we're going to do this afternoon. And then we're just going to do some social time and Q&A. All right. I'm also going to be looking. I have my eye on the live channel in Discord. So if you want to write there as well, you're more than welcome. All right. So let me officially start this stream now that it's been 9 minutes. All right. Good afternoon, everyone. My name is Jose Luis, and for those of you who may not know me, I run this channel called Parametricom where we do live streams and tutorials on computational design. Okay, and if you're new to this channel, which I believe I see a lot of familiar faces in the chat anyway, but if you're new to this channel, I just want to let you know that they're in the middle of recording a full playlist of called Learning C# Introduction to Computer Programming for Designers, where I am teaching you, hopefully, the basic skills of how to write computer code, and I'm using C# as the language. We're doing vanilla C# here because I want to finish this playlist with all the basic programming concepts in C#, and then I will start creating more playlists now that once we know the basics, where we start looking at how to write C# in other environments, like for example Grasshopper, Unity, perhaps Dynamo, perhaps VVVVV, who knows? Like anything that we might consider interesting. Okay, but I really want to get the fundamentals ready so that once we know how to code, we can start doing more advanced stuff. And for those who might join this channel and the work that we do here later, they can always go back to the playlist and then start learning from there. So, today we have covered a lot of stuff already: variables, conditionals, for loops, iteration, and we've done a lot of examples. And today we recorded a new exercise that was basically just ASCII art and ways of using nested for loops to draw graphics on the screen. That was very nerdy and very interesting in my opinion. And a couple other episodes that I'm not really sure exactly where I'm going to put them together right now. So what I would like to do today is I'm going to do an introduction to data structures, and I'm going to explain today how to write lists and how to write arrays in C# and their differences. I need to do an episode about, let me just write that down. The differences between lists and arrays in C# is very important, when to use which one or the other. Okay. So before we move on, do we have any questions? Anything you want to touch upon before I start recording? Anything you want to share in the comments? You're welcome, Discom. I appreciate doing this a lot too. I'm going to, and in the meantime, this is the file from this morning. So I need to create a new, and that's going to be 31 lists. Yes. Should I start with some kind of introduction to data structures? Maybe I could also do an introduction to objects, as in for example the console object, the math object. Interesting. And what is another object that we could create ourselves? What is a class that is available on the vanilla framework that we could instantiate? Because we can't really instantiate a new console object, right? So if I say read key, and if I instantiate, I cannot instantiate like a console object. It's probably private, right? Yeah, this doesn't work. It doesn't have a public. Yeah, it's a static class. This doesn't work. And I don't want to introduce libraries yet. I may talk about objects just as a brief introduction. I'm going to introduce objects because that's by far the most important one, but I will talk about how to create them farther down the road. Yes. Okay. All right. So lists. Let me. Let's see if we can C# lists, C# collections, programming concepts collections. Using a simple collection, classes. Okay, so this array list, hash tables. Well, I think I can probably start here. Okay, this is going to be, I'm going to do an intro video, then I'm going to talk about lists, and then I'm going to talk about arrays, and then their difference, and then I will talk about objects. Okay. I would like to start a new section of this playlist on how to learn C# code and how to learn how to program by talking now by introducing data structures. Data structures are basically a more complex data type because what we have seen so far in these videos is how to create variables that store simple data types, such as primitive data types, such as, for example, numbers, Boolean values, strings, things that are can be stored as a value or can be stored in a very simple numerical representation. But obviously, in computer programming, we need to find ways to store other kinds of. No, I'm not liking where I'm going with this. I'm not liking where I'm going with this. So I'm going to they kill that. Classes, objects, classes, reference types, class instances, declaring classes, collections, arrays, C# arrays, programming guide. Okay, I think this is what I want to do. I'm going to talk about collections, arrays, classes, and objects. Okay. Hey, Kartik. Good afternoon. How are you doing? Good to see you. Okay. Let's start over again. Starting over again. Okay, let me start a new section of this playlist, Learning C#, Introduction to Computer Programming. Let me start with this section by discussing how, so far, what we have learned is how to store data by creating variables. And most of the types that we have worked with so far have been what we have referred to as primitive types. So simple data entries that can be represented numerically in a very simple way, such as, for example, Boolean variables, numbers with decimal part, numbers without decimal part, and even strings, which we have already discussed how they have a numerical representation as well. However, in computer programming, there are other ways where we can represent and we can store more complex data types that actually have a lot of information embedded in them, whether if that is as different properties or different variables within a particular variable, or whether if they actually represent collections and lists of individual entries of data. C Sharp and any other programming languages have a lot of these more complex data structures that allow you to supersede simple primitive types and store more complex information. In this section, I would like to talk about, I would like to introduce some of these more complex data types, and I'm going to be discussing in this section two data types that are fundamental for storing large collections of data. One of those is going to be lists. So if you go to the C# reference guide, you can see that it has a whole section called collections of the different types of data structures with their different properties, such as, for example, lists. Where is the wait, sorry. Here, like lists, like dictionaries, sorted lists. Like it has like a lot of different types for storing collections of data, and how and they differ in how they work and what are they designed to be doing more optimally. What we're going to see in this section is lists, and maybe farther down the road in more advanced playlists, I will talk about dictionaries, queues, or stacks. And then I'm also going to introduce another super fundamental structure called arrays, one that allows us also to store sorted lists of elements. And I will explain how is it different from lists, how is it different from collections, and when to use one or the other. And finally, I think in this section, I am going to introduce all of you to the concept of classes and to the concept of objects. Objects and classes are also data structures that contain properties and that contain functionality inside of them. And they're typically used to represent notions in the real world, such as, for example, a car, a person, or all these other things. And I'm going to do like a very superficial introduction to this. I'm just going to basically teach you what they are and how to use them. But I will do a full section later down in this playlist on object-oriented programming, because classes and object-oriented programming is fundamental, is the jewel of the crown in paradigms when it comes to modern programming languages. Most of the programming languages that I use every day, they have some form of object-oriented programming within them. So it's very important that we actually spend some time together with this, and I will do a full section with a lot of episodes on topics related to object-oriented programming. But then, without further ado, let's start by taking a look first at collections to store large amounts of data. Follow me up on the next video. Alrighty, so I'm going to move this somewhere out of the way, and then I'm going to drop here lists. And this is absolutely unreadable. It's very difficult to take. So let me create number 0 is going to be 0. Integer number 1 is going to be 5. Integer number 2 is going to be 10. Integer number 3 is going to be 15. Integer number 4 is going to be 20. Integer number 5 is going to be 25. Integer number 6 is going to be 30. So I'm going to use this to represent how obnoxious it would be to have to store data in this way, right? Number 9 is going to be equal to 45. And then integer number 10 is going to be equal to 15. All right, and I'm going to copy paste this. I'm actually going to copy and paste this. And this I'm going to write here. How's everyone doing? Okay, so let's do this. um, um, yeah, I'm not even going to bother with this. This is just going to be confusing, and there's no point. And it's just, we're not here yet. No. Iterate. A video on iterating, particularly over elements on a list. Can I iterate with for each? Can I iterate over for each C#? Can I iterate over elements of an array? Does that work? Yes, it does. It looks like it does work. Well, I can just try. For each integer in array, it does work. So maybe I have to use this for loop. Haha. Of a list array. So that's going to be another video that I'm going to do. Yes, so I want to do that video. All right, so there we go. So now let's talk about lists. Wonderful. Let's start by taking a look at lists, okay? And lists are structures that allow us to store a sorted collection of elements one after the other. Very simple, right? And why is this? It is because let's say that I wanted to store in memory a sequence of numbers. For example, the numbers from 0 to 50 in steps of 5, for example. If I wanted to do that with the techniques that we know so far in this playlist, what I will need to do is I will need to do something similar to, for example, let's say I'm going to declare a variable called number 0. That's going to be 0. Another number called number 1, which is going to be number 5. Then number 2 is going to be 10. And then so on, and end up writing a full list of individual variables that store individual digits. So I could use this to now maybe write some of them to the console, but this is very tedious. It requires a lot of typing, and it's not practical because if I now wanted to change, for example, the scale of these numbers, and instead of 5 units of 5, I wanted units of 2 or units of 10, then I would have to manually change each one of the numbers. And if I wanted to add more, to, for example, up to 10, 20, even 100, it would just be impossible to maintain this by typing everything manually. So there has to be a way to declare programmatically, to declare with code, a structure that can hold and maintain all these values one after the other, and that I can access in a more programmatic way. And that is where lists kick in. Okay? So how would we write this in a different way? Well, lists are like any other variable, are things that you can declare as part of your program. So you can declare a variable, for example, that I'm going to call numbers, and then I can declare that this can be a list of integers. So for example, something that I can do is I can say I'm going to write here the fact that this has to be a list of integer values. Remember that C# is a strongly typed language, and we have to specify the type of everything that we do. So the way we do that is list. We can have lists for any type of data. So the way to specify that the data that this variable is going to contain is integers is by using this angular notation, opening and closing angular brackets. And then, so this is the declaration. And then the way we create a new empty list with no numbers inside of it is by using this particular syntax that we will start understanding more deeply down the road in this playlist, which is a new list of integer values, and I'm going to open and close parentheses here. Okay. As of right now in this course, we don't really know exactly what these angle brackets mean here. Why do I have a new keyword here? Why do I have to open and close parentheses when I declare this object? But I'm going to ask you to trust me on this one at this point, because it will take me a few videos to unfold where all of this is coming from. But the idea is that anytime that I want to create a list of elements, I can do so by defining the variable, defining that it's a list of whatever type is going to be contained here, and then using this same syntax to create that list. Okay? What does this also mean? It also means that because I'm declaring the type that is going to be stored in the list, it follows that lists in C#, this is different in other programming languages, but in C#, lists can only store the same type of data. So if you clear a list of integers, you cannot store strings or doubles or any other type inside of them. You always have to be consistent with the data type that you store on the same list. Then, if this is the case, then at this point we have an empty list of integer numbers. Okay? Now, what can I do to start adding elements to this list? So what I can do is I can say, well, to the variable numbers, if I click dot, then what I'm going to do is I'm going to access a particular set of the properties and the methods that, that lists have available to work with. We also haven't seen this yet, this idea of the dot notation and accessing properties. We've seen similar things with the console object and with the math object, but I will explain actually by the end of this section the idea of classes with methods and properties. Okay? So if I hit dot, I can now scroll down and see all the functionality that is available for lists. All right. So for example, the most important one, probably it's already recommended here by IntelliSense, is adding a list to this element. So I can now click add, open and close parentheses, and then I can just add a new integer element to this list. So for example, 0. And then I can copy and paste this a bunch of times and say like, this is going to be 10, this is going to be 20, this is going to be 30, 40, 50, and 60, and whatever. Okay? So we're good. Now, what is the next thing that I may want to do with this list? Well, maybe I'd want to print the values of that list to the console, right? So how about we do that? Let's say console write line, and let's print all these numbers to the console. As I do that, I'm going to hit execute, and the window pops up in my other screen, so I'm just going to put it here, okay? And then something strange happens. What it happens is that I don't really get a printout with all the numbers on my console. And that is strange. What I get is this really strange printout like system collections generic list system integer 32, which I'm not really sure what this means, but it's not what I expected. The idea of what's happening here is that what I have asked the computer to print out to the console is the whole list, is the list variable, okay? And that doesn't mean that I'm asking the computer to print any of the particular elements that are inside of the list. And therefore, because the computer doesn't know what to do with this object that has been passed to it, it basically prints the data type, the full signature of the data type of this object in the console. All right. So that is not exactly what I wanted to do. Probably what I wanted to do was to print out one by one each one of the elements of my list, right? So the way I can access and read each one of the particular elements of my list is by using what's called the square bracket notation, to point to a particular element on my list and then print that and then read that value and print it to the console, for example. So let's say that I want to print the first element of my list to the console. Then something that I can do is in here, in numbers, I can open and close square brackets, and then inside of the square brackets, I can input the position of where that object is on the list. So if I want the first object of my list, then I might be inclined to say, let me put here the number 1. And let me show you what's going to happen. If I do number 1 here, the number that prints out is not 0, which is what I expected. That was the first number I added. What I get is the value of 10. This is one of the biggest mistakes, or one of the biggest things that it's easier to forget when we're learning how to program. And it is the fact that most computer programming languages start counting element positions with the number 0, not with the number 1. So it turns out that the element that is at position 1 on a list is actually the second element on that list. So if I wanted to actually print the first element, I need to substitute this with the value of 0, okay? And then that's where it just prints the first element of my list, okay? And if I were to print 1, 2, 3, 4, 5, 6, there's 7 elements in my list. If I wanted to print the last one, what I would need, if there's 7 elements, I would need to print the element in position number 6. So that's going to be this one here. Is that clear? Wonderful. Now, square bracket notation is also, before I forget, it's very important that when you are pointing to elements on a list with a position, it's important that you do it right, and that you're pointing to an element or a position in a list that actually exists. If this element has 7 elements, and I point to element number 7, for example, remember, that would be like 1 over the capacity. What's going to happen is that I'm going to get an error because I'm out of range. There are not enough elements. Remember that if a list has 7 elements, the last element of that list is the one in position number 6. So there's no element in position number 7, and therefore my code breaks. This is one of the most common reasons why beginner code breaks, is because we're trying to access data on a list or an array that doesn't exist. Okay, so let me go back here to number 6 or number 0. Another thing that we can do is we can manually override values on a list. Okay, so for example, I can use the square bracket notation not only to read elements, but I can also use it to, if the element already exists on the list, I can use the square bracket notation to point to that element and change the value. So for example, I have created the list. I have 7 elements in this list. Now what I can say is like, the first element that I added, for some reason I don't like it anymore. Let me change that. So I can go ahead and say numbers, the element in position number 0, whatever it was before, I don't care anymore. I'm going to write the value of 2 point something something something. But wait, this gives me an error. Why does it give me an error? Because I am storing numbers in this list, but remember that lists are strongly typed. So if I said that these numbers have to be integers, it's not going to let me store a number with decimal part. So I'm going to substitute this by the number 23, for example. And if I were to print now this list here, you can see that I get the value of number 23. All right. Then another thing that I can do is wait, I'm blanking here. Let me rewind that. Let me rewind that to where. Let's rewind to what I was gonna start. What am I going to explain now? What am I going to do now? Okay, I'm going to print all the elements to the console. Now let's go back to what we wanted to do at the beginning, which was to print all the elements of this list to the console, one by one after the other. If we know that we have 7 elements on this list, that it turns out that what we could do is like we could do, let's print this, the first one, the second one, the third one, the fourth, fifth one, and the sixth one, right? And I mean, technically that is going to work, but what do we think about these techniques of like copy pasting code and changing numbers? It's not very programmatic, it's not flexible, it's not going to let me, because if I were to now start adding more numbers here, right? 70, 80, 90, whatever, if I were to do that, then now I would have to remember to change the code here and add more lines to print more elements. And if this is one, right, one after the other, maybe I can remember. But if these two parts of the code are separated by a million lines of code in between, then I'm definitely going to forget. And also, if your list had a million elements instead of just 10, then it would be very tedious to do this. So there has to be a way to print all the elements of the list programmatically. And as you may suspect, we've already seen structures that allow us to perform the same operation over and over again with slight variations. And that operation, those are for loops, for example, or any iterative structure that allows me to perform the same operation over and over. So I'm going to substitute this. I'm going to remove all of this. And what I'm going to do is I'm going to place this inside of a for loop that is going to start at 0. I is going to be less than 7. Okay. And then I is going to be plus plus. And then I'm going to place this here. And inside of the position number, what I'm going to do is, instead of hard coding the number, I'm going to write the variable I in here, so that with this for loop, I'm iterating from the numbers 0 to the number 6, right? Because mine is less than 7. And for each one of those numbers, 0, 1, 2, 3, 4, I'm going to print each element to my list, and then to my console. And then if I do this, now I get a nice printout of all the elements of the array here. All right? How awesome is that? Well, this is great, but you know, I am very stubborn, and I want to make you like really pro computational designers and programmers. So this code is starting to be much better, but it's still not great. It's still not fully programmatic, because again, if somebody were to add more elements to the list, now it just so happens that I would have to remember again to go to that for loop and change the number 7 to whatever, and I would actually have to come here and count how many lines there are, etc. Not great. So there needs to be a way, if I want this for loop to always print all the elements that are contained in the list, there has to be a way to figure out programmatically, to figure out with some kind of rule or some kind of technique, always the number of elements available in the list. And it turns out that there is. So if I go to the number 7 and I replace this with numbers dot, and I press dot, I start accessing not just the functionality like add, but I can also access properties of the numbers list. And those properties are things that tell me characteristics of what the list is doing or how the list is behaving. And one of them is the word count. And as you can see here, the signature of this count property is that it gives me back an integer value, and it gets the number of elements contained in the list. So if I click here and I say numbers.count, I know that this property, which is kind of like a variable that exists inside of the list, this property is always going to give me a number that represents how many elements are contained in this list. C# takes care of maintaining that. I don't have to do anything with that. C# is the one who makes sure that that number is correct. And then with that, now I can say I'm going to print this. I don't even know how much count it is, but I know that it's the right value to print all these numbers here. And if I now programmatically reduce the amount of elements, I still know that the for loop is going to adjust exactly to the number of elements on my list. So this idea, using a for loop to iterate from 0 to the number of elements in an array minus 1, so I is less than that value, one at a time, and then use the variables, the values of that list for whatever purpose, for printing them to the console, for creating a geometric object, whatever, is so common that actually very commonly, the reason why the variable name for the variable that we use inside of for loops is typically the variable I, is because this refers to the index number or the index position of elements in a list. For loops and lists are such good friends that they're usually written in tandem very often. And in early computer programming, for loops were basically the structure that was used to manipulate, to store, and to create also lists and arrays of information. Okay, so this is what we use to print all elements to the console. Lastly, something that I want to talk about is the fact that you have heard me like complain so much about writing programmatic code, not copy pasting lines of code. And when we were declaring and we were adding elements to that list, that was also not very programmatic because it was very manual, very handwritten, right? I had to copy pasted this line of code 17 times. So if what I wanted was to programmatically create a list of numbers and store them as a list, and there was a logic to the sequence and the order of those numbers. So for example, here we kind of wanted to create a list with numbers at 10 unit intervals, right? So it's very simple to write a rule for that. If there's a rule that we can write, then making this, copy pasting these lines and writing them manually, it's definitely not a programmatic way to do that. And you probably know where I'm going with this. What structure do you think we could use to programmatically populate a list with a lot of values if we know the rule that those values are going to follow? I'm going to give you 2 seconds. Ta-da! Exactly. You probably guessed it. We're going to use a for loop here to populate a list with however many values we want from starting at 0 and at increments of 10 units. So for example, here I'm going to say for int equals 0, I equals 0, I is less than numbers dot count, and then I plus plus, and then I'm going to do this, and I'm going to add here the value of 10 times I. Okay? And if I run this code, I think I'm actually going to get an error, right? Yes, I'm getting an error. This is not working. What did I do wrong here? I very much stress the idea that here we should be able to read programmatically how many elements are in an array, in a list, but I don't think that's what I want to do here. It's not what I want to do there because at this point in the life of the program, numbers is empty. Numbers has no number has no elements here. So if I create a loop between I is 0 and count, which is also 0, then this for loop is actually never going to iterate any cycle whatsoever. So when I create elements for a list, that case is a case where I actually may want to hard code here either a number, so I'm going to do here, for example, 25 elements, or where the number of elements that I might be using here might be coming from some other rule in my program, or might be coming from user input, so from typing in the console. So maybe I can just say like elements is going to be, for example, 25, and then here I'm going to create a for loop where I'm going to iterate elements times and then create that many elements in the array. So now you can see I got my list of data, which is numbers from 0, which I manually overwritten here, to 250, 250, 240 at intervals of 10 units. So using for loops to populate data lists, using for loops to read data from lists, and using for loops to manipulate that data. So for example, I could be doing here, I could write a for loop here that says take each one of these elements and multiply it by 2. Okay? And then the result of that is going to be that they're going to reach almost 500 units. Okay? So the idea of manipulating data with for loops, creating data on lists with for loops and reading it is so important that I don't know if I've told you about like tattooing like cheat sheets on your arm, but probably this is something that you also want to find some space on your arm to tattoo on. For loops as the best friends to create and to read data from lists. Okay. So with this, the only thing that I want to mention as well is that very typically when it comes to lists, because when you declare them, it's a little tedious. You have to type like list and then the type and then the other stuff and then the other type. You will very often see out there in the wild how people, when they declare lists, they use the implicit type operator. And we have a chapter, we have an episode before in this course where I explain what this means. But this is basically a way of like shortcutting, having to define manually what the type is going to be. And then the type becomes implicit by this declaration, this constructor here. When I teach, I like being very explicit about things. So I'm going to leave this with the full type signature here. All right. And with that, I think this is everything that I wanted to explain, the basics of lists. If you're interested in more, you can always go to numbers, dot, and then figure out all the stuff that you can do with lists. So for example, you can add range, which means taking another list and attaching it to this list, therefore concatenating two lists. You can, for example, see how much capacity it has. You can clear the list, so I can just forget whatever it had, just wipe it out. I don't want it anymore. Or you can also use, for example, remove at and type there the position of the element that you want to remove. So I have a long list. I want to remove one element in the middle for some reason. So I can remove the element at position number 5. Okay, so there's a lot of stuff that you can do with lists. They are a very flexible and very mutable structure. It's very it's very nice and very easy to use in C#, and I highly recommend you take a look at you give it a try. Okay. I think in the next video, what I'm going to do is I'm going to explain arrays of data, which are a very similar structure, but it has a few nuances of things that we need to keep in mind. And then in the third video, I will hopefully explain what the difference between lists and arrays are and when to use one or the other. So stay tuned for those videos further down in this course. All right, that was messy. Woohoo! Okay. Oh. I am going to. Oof. Should I go? How did that go? Did you know these concepts? Was it new stuff for you? Let me know in the chat. I'm gonna take a 1-minute break. I'll be right back. Alrighty. Thank you, Kartik. All right. What is next? Arrays. Okay, let's take a look at arrays. How does that work? So that's going to be here, 32 arrays. And then let me, okay, so console read key. It's kind of annoying to have to do this all every time. Okay. Oh, wait, let me start. I messed up. All right, Visual Studio. I don't know how you're feeling, but I'm ready to start the weekend. Okay. All right. So that's going to be arrays. Okay. I run this. Oh, and it's here already? Well, that's nice. Okay. So, arrays of data. How are we going to start that? So I'm going to start by explaining, well, we've seen lists. Now we're going to explain a very similar structure. It also represents data that is ordered and that can be accessed via position with the square brackets, but we're going to explain how it's declared differently. I'm also going to write a couple of for loops to populate the data, and then I'm going to explain that we have to use length instead of count in C#, and then I will not get into the nitty-gritties of their differences until the next video. Okay. I also want to explain that lists are a bit more C# oriented, but arrays are basically present in any computer programming language that I know. Oh, thank you, Alka. Okay, so may I actually just open lists? I'm just going to open this and have it in the background when I start, and then I can start talking about arrays. Or just not do that. Okay, I can do. I can just do this. Okay, let's get ready. In the previous video, I have explained how to store collections of data, so sorted lists of elements one after the other, using C#'s list structure. Okay, which is great. It's very flexible, and it's very handy. I use it all the time actually when I write C# code. But in fact, in a way, lists are a very C# specific way of storing information, storing sorted information. But there's actually a different type or a different structure that is way more fundamental in computer science terms, and it's actually shared by pretty much any programming language that I know of, which are called arrays. Okay, arrays are a very similar structure, and they also store sorted lists of elements one after the other. And it's only that they have a few differences that with lists that I'm going to explain in the next video. So, but you will find them very often in C# as well, in any other programming languages. So I think it's very important that we take a look at how to create them. and how to use them. And then in the next video, I will explain about when to use arrays and when to use lists. Okay? So let's say we want to do a similar example to the previous video where I created a list of numbers that went from 0 to some value at some particular increment, whatever. Okay? So what I can do is I can say, instead of a list, this time I'm going to create an array of integers. And the way that works is that I also have to type the array. And if you're coming from the previous video, you may say, oh, so you probably want to do something like this, an array of integers. That kind of makes sense from a design perspective, but no, that's not how it works. The way you actually the way you declare an array of integers is by typing the word integer, and then after that, opening and closing square brackets with nothing inside of them to signify that this item here, this variable is not anymore one single integer, but it's an array of integer. And actually this syntax is shared among other programming languages, like for example Java. Java also declares Java and C, they also declare arrays like this, not JavaScript. Now, we also, when we declare an array, we also have to initialize it. And we also have to use like a version of that strange constructor flavor that I was showing before when it came to lists. So I also need to use the new keyword. I also need to specify again the type that I'm going to be using. But now in this case, there's one very important difference, and it is that when I declare and when I initialize my array, I actually have to specify how many elements will be stored in the array. I need to say that and define that from the beginning of the array, since the very early start. What that means is, for example, let's say that I will want to end up with 25 elements in this array. So that's going to be, I'm going to type here the number 25. So at this point in my program, I have an empty list, an empty array of integers with 25 slots that I can now use to go into one of them and populate them with data. Okay? So how will I do that? Similarly to what I shown before, for loops in this case are your best friends. So what I can do is I can say I'm going to create a new for loop that is going to iterate from the index number 0 to the index number, probably the index number 24, right? So I'm going to, to the index number 24, so I has to be less than 25. And then I'm going to I++, and then I'm going to say numbers I is going to be equal to whatever. So for example, 5 times the position, so that I get 0, 5, 10, 15, 20, etc., etc., right? And similarly, I can now write another for loop where I say I'm going to iterate from index 0 to index less than 25, so 24, and then I want to print to the console each one of those values. All right? So I'm going to print numbers I to the console. If I execute this code, you can see that I have pre-populated the array and I have added all these numbers, and now I have an array that contains all these elements. One thing that is interesting is that when an array is initialized, because it's initialized with 25 empty spots in this case, if I did not pre-populate that with any information, if I didn't go one by one and added any information there, something that would happen is that those positions are holding the default value for whichever type I'm using for that array. In the case of integers, is 0. In the case of doubles, it's also 0.0. In the case of booleans, I believe it's false, and so on and so on. And for strings, it would be an empty string, like a no characters. So you can choose to initialize it and give them value, or you can choose to just keep them empty, and then as the program evolves, start working with that information. And if you're coming from the previous video, you may be surprised that I've hard-coded here the number 25, which is true. This is not very programmatic, because now if somebody, like my team member, my former self, whatever, changed this capacity of the array, then I would not be printing the 50 elements to the console. Or even worse, if somebody reduced the array to 10 elements instead of 25, I would get an error. I would get an index out of range error, because at the point at which I'm iterating and I becomes number 10, there's no element anymore in the position number 10 in this array, and then my code crashes, my program crashes, stops executing, error, terrible programmer, boo. Okay, so what we need to do is here somehow programmatically, we need to figure out how can we get dynamically, how can we get the amount, the size of this array. So something that we could have done is, we could have done, for example, just declare a variable called capacity, right? And then say, this is going to be here, and then I'm going to use the same variable in any for loop that refers to that array. And that is not a bad technique, okay? And in like very low level programming languages, that is a very common technique to use. However, thankfully, arrays have a smarter way of doing that, and it is that arrays also have a property similar to the one that lists had. Remember when we read how many elements a list has using the property count of the list? In the case of arrays, we have the exact same similar pattern. In this case, instead of being count, we use the word length to read how many elements this array has. And similarly here, now we can get the value of how many elements are in the array by reading the length property of that array. I know it's a little confusing. Why count? Why length? It's just by design. It was a design choice that somebody made when designing the C# language. Okay, and now my code is much more programmatic. Everything is much tighter, because if I change the size of the array, everything adapts, and everything populates correctly, and everything prints out to the console correctly. So these for loops are never going to fail according to the array, and are always going to do the same job. So arrays are also a structure that allows us to store sorted information one after the other, to access that information, to write it or to read it based on a position. And remember, position always starts with a number 0, okay? And the last element on an array is the element of the length minus 1. So if the array has 10 elements, the last element is in position 10 minus 1 equals 9. Arrays are structures that are a bit less flexible. So for example, if I go to numbers and I look at the properties that we find, it has less properties, and many of them are actually inherited from parent structures. We don't know what that means yet, but it's basically, there's less things you can do with arrays. But there are also advantages about why that is the case. And I would like to explain some of those in the next video. So this is, I think, the fundamental of how to create arrays of data. Just the declaration is a little different from lists. And how do you read how many elements? It uses a different property name, but the same. The rest, the square bracket notation for accessing and for changing values is the same. The difference is that you have to initialize it to a set number of values, and for the most part, you cannot change the size of the array. You cannot really add elements to the array or remove elements to the array. That's not entirely true. You can actually do that, but it's just a really, really expensive operation. So if you're going to be doing that, you better be choosing a list structure. Let me get to those things in the next video. Stay tuned for that. All right. Arasto, how are you doing? Alka, can we have a list of arrays? Of course we can. Everything is, of course we can. Let me do, oh, that is really, really nerdy. So we can have a list of integer arrays. What? List of arrays, and then this can be a list of, there you go. This works perfectly. Yep. It's just that now when you use your for loops to populate this with data, then it's going to be a bit more complicated because you're going to have to create and for example, j is less than 0. J is going to be, for example, I'm going to have 10 arrays in the list. So that's going to be j10. So now each one of these, what I need to do is like list of arrays. Let me add a new integer array with a capacity of 100, for example. All right. And now in the nested for loop, I can say int I equals 0, I is less than list of arrays, the element in position j of list of arrays, and I plus plus, and therefore, and what am I getting here? List of arrays dot length. Okay, and now here I can start to that array. I can say this is the list that contains the array, and now here I'm going to add the position of the array element. This is a little complicated, and this is now I, for example, 10 times I. Woohoo! That was quite something. But yeah, so basically, this square bracket is referring to the first is referring to the first list, the second list, or the third list, right? And then, no, sorry, it's referring to the first array, the second array, the third array, and that's why for the first array, the second array, or the third array, we can get the length property, and then this refers to the array, and then this refers to each element of that array. But yes, I have not yet encountered a situation where I've needed to do this, because if you want to do something like this, you're actually better off. Wait. Am I messing with? Yes, I don't. Sorry. Let me go back to, because I need to save these files. Exactly. Let me go back to this, because if you need to have nested data inside of nested data, you're actually better off using two-dimensional arrays like this. And this can be a new, and then this can have, for example, 20 rows and 30 columns, and actually no, I think two-dimensional arrays in C#, they are declared like this, right? Yes, they are declared like this. So this is how you declare two-dimensional arrays, but we're not going to get there yet. I want to talk about two-dimensional arrays, but I want to talk about that in the future. It's a little messy today to do it right now. So I'm going to write that to the arrays as future videos, okay? All right, where was I? Yes. Okay, what is the next thing? Oh, difference between lists and arrays. I had a diagram somewhere. Where is that? There you go. I think, actually, why don't I just use this? Yeah. I can just use this from my class. One of the slides from my lecture in the class. I can probably just use this. Okay. All right. So the difference between arrays and lists. Okay. In the two previous videos, I have just explained how to construct and work with lists of data in C#, and I have also explained how to construct and how to work with arrays of data as well in C#. And I have mentioned here and then that they're very different in how they work internally, and there are certain situations where we would want to use some or the other. Okay, so I'm going to use this diagram that I found on Stack Overflow here on this link here. You're welcome to check it out, actually, and that I'm using for it was a very good response about this difference, and this is the slide that I use for my introduction to computational design class. The idea is that lists are a structure that is very flexible, because when it is stored in memory, the idea is that each one of the data points that you have on the list, each one of the numbers or the strings or whatever type you're storing there, is stored somewhere in memory. Okay, and that somewhere in memory might be anywhere in your whole computer memory. It doesn't matter. They don't have to be contiguous one after the other. And how lists know which elements go after the other is that when the computer saves one element, adds one element to the list, when it adds the second one, what it does is it goes to the previous one, and it saves also on the previous element, it saves the memory address of where the next element of that list is to be found. So that what that means is that internally, a list has in memory for each one of the elements, it has the information for that element, and it has an address, a memory pointer that points to the next element that is on that list. And so on and so on. So each one of the elements can be anywhere in memory because it knows where the next element is going to be, and it can point the computer to that location. That is how lists are stored in memory, but the way arrays are stored in memory is different. Because what the computer does is that, okay, you're telling me that you want 10 elements, and those elements are going to be integers. So I know that I'm going to store those integers as 32 bits. So I know that 32 bits sometimes I need 320 bits of free memory contiguous in the same block to store this array. So the computer looks at the memory, finds a large spot of memory, and saves that whole thing for your array. That is the reason why we need to declare first. We need to declare the type of what we're going to save so that the computer knows each one of those boxes, how much memory it needs. And also, we need to define beforehand how many elements the array is going to contain so that it can find 10 blocks contiguous in memory. The advantage of that is that arrays are really, really performative. They're very fast to read and very fast to write. Because since all the information is in memory next to each other, then when you say, for example, can you give me the fifth element of an array? The computer knows where the first element is because it's somewhere in memory, and it knows that each element is 32 bits. So it knows to move right away to element bit 160, and it knows that the fifth element is going to be right there. And for 10 elements, that might be blazing fast, but for 1,000,000 elements, if you have an array of 1,000,000 elements, that actually matters a lot. And that is what's called random access memory. Is the idea that by knowing the size of the elements and the location, you can very easily go to that position and read that element very fast. Whereas with lists, it doesn't really work that way because since the elements of a list can be anywhere in memory, it turns out that theoretically, the way to find the fifth element of a list is by starting with the first one, going to the memory, finding the memory for the second one, and the second one reading the memory address of the third one, then going to the fourth one, going to the fifth one, until you find the one that you want. And again, for 5 elements, this might be really fast, but for 1,000,000 elements, in order to get the last one, you kind of would have to go through the 1,000,000 before, which will take some time, right? At the same time, lists are a little slower when it comes to retrieving and accessing information, all right? Even though C# actually comes up with a lot of optimizations and tricks to make this process not so heavy, okay? So, but we don't really need to get into that. And so that is one of the disadvantages of lists. The other disadvantage is that for storing the same amount of data, lists need more memory, because not only do they need to store the same amount of data, so they have the same memory footprint, but they need more memory to store the memory pointers from each element to the next one. So the memory demands of lists are much larger. So, well, if that's the case, then why would we want to use lists? Why would we want to use lists and not always stick to arrays that are so fast and so performative? Well, first of all, there will be a lot of situations where we actually don't know how many elements we're going to be working with. Okay, so if I load external data, or if I'm changing things as inputs are coming, emails are coming, whatever, storing an email database, say emails are coming, so I need to keep storing them somewhere, right? So if there's uncertainty about the number of elements, then lists are a bit better in that sense. Also, because arrays are a full block of data, one next to each other, then you can't really decide to take the third element of the array. That doesn't work. What you would need to do is you would need to say, okay, what I'm going to do in order to remove this element is to actually take all the elements afterwards and then start copying them and moving them one position before, which is actually a kind of expensive operation. And even so, you would need always end up with the last element being 0 or whatever. You can't really remove that. In order to truly change the size of an array, what you actually need to do, say I wanted to remove the first 2 elements of this array. What the computer actually does is that it finds a new spot in memory that can store 8 elements, and then it blocks that spot, and then it copies one after the other 8 elements that are remaining from that operation. So changing the size of an array is actually a very expensive operation, because you have to literally copy the whole array into a new memory location. Whereas with linked lists, changing and removing elements is actually quite simple, because if you want to add a new element to the list, the only thing you need to do is like find somewhere in memory where you can store that one element, and then go to the last element of the list, and there store a memory pointer that points to where I just added that element in memory. The computer C# takes care of doing that automatically for us. We don't need to maintain that. And also, removing an element is also super cheap, because the only thing that I need to do is, say I want to remove this guy from the list. The only thing that I need to do is go to the previous element, and then wherever the memory address here is pointing to this element, now don't do that and overwrite that with a memory pointer that is pointing to this one. So take this arrow, and instead of pointing here, just point to this one. And therefore this element is forgotten and is not part of the list anymore. So it's a very simple operation. So long story short, when you know a priori, when you know beforehand how many elements you're going to be working with, and those elements are not going to change, but the size of that elements are not going to change, then arrays are probably the best choice that you want. However, if you have a certain level of uncertainty, if you don't know how many elements you're going to be working with, if you need to add elements to your list, if you need to remove, if you need to change the size of your list very often, then lists are definitely the structure that you want to choose for that operation. Arrays, changing the size of arrays, is a very expensive operation to do. Okay, so these are kind of the two options and the main differences. Many programming languages have versions of arrays and linked lists, and in C# we just saw literally arrays and lists, and these are the disadvantages and the advantages of using one or the other. Okay, I hope that was clear, and let's move on to the next video and see what other things we can do with arrays and with lists. Alrighty. Sujai. What's going on here? Did you mention the pi word? You know I'm not a fan of pies in any, Sujai. So the array is the same as a NumPy array in Python. um, so, well, Python has arrays with a square bracket notation, but in fact, I believe that under the hood, Python arrays are actually linked lists, like the one that I just explained. So that's one thing. I think NumPy arrays might be optimized to also be to have like random access properties, so that might be closer to arrays. But in fact, Python is such a high-level language that the implementation of their arrays depends on the user. And I'm not entirely sure about what the actual implementation of NumPy's arrays or regular arrays or lists in Python, what that looks like. So, but that is worthy of some Googling and then like checking it out. Alka is asking whether if it's either lists or arrays. Well, remember that a variable can only have one type. So it can be either an integer, an array of integers, a list of integers, or like we saw before, maybe you want to combine those and do a list of arrays of integers. But honestly, I have never been in a situation where I thought doing a list of arrays was a good solution. Even though now that I'm thinking about it, I could think of a couple examples maybe. Not entirely sure. But yes, typically you either use one or the other. Could you have empty elements, null values in an array? You can. So in C#, you can have null elements in an array as long as the type that you're using is a nullable item. What does that mean? You cannot, for example, if you have an integer value, right, a, for example 10, that is a primitive, and primitive values do not accept null as a value. So here I cannot have null, it will give me an error, okay? Because I cannot convert null to an integer because integer is a non-nullable value type. What about strings? Strings, I'm not sure. Can you store null in a string? I think you can, yes, because it's a more complex object. You can have a null string, but you cannot have a null integer. You cannot have a null boolean, right? So this doesn't work. I cannot also, well, I cannot use this word, whatever. So this is not a nullable type. Doubles are also not nullable, you know? This doesn't work. And therefore, an array of integers or a list of integers cannot have null elements. In order to do that, you would need to define that this type is a nullable type, can be a nullable integer, and you do that by adding the question mark here. So if you declare that if you add these question marks, then you're changing the type, and you're making this type a special type called a nullable primitive, which has its own properties, but basically it allows you to store null values. And there are some situations in which you actually want to do that. It's quite handy. But this is a pretty, I would say it's a more advanced topic. I don't think I want to get into that yet, especially because we haven't talked on the course, on the series, about nullable types or like objects or classes. So yeah, so the answer is not for the most part, but there are some cases in which you can actually try to do that. So what are we doing now? What are we doing now? Iterating over elements of a list or an array. We're going to look at iteration for each. Sujai. Okay, you guys know I'm joking about me hating Python, right? I just find it funny, and I like how people think that I hate Python, and they make jokes about that. I also like that, but I'm actually cool with Python. I just happen to like JavaScript better, but that's a very personal opinion, you know. Okay. Iterating over elements of a list or an array. Okay. Varvara, seriously? Please don't bring out the dirt here. No, we cannot. And also, you have privileged information, so don't don't go there. All right. Um, so where are we doing this? Um, mm, mm, mm. So what are we doing now? Yeah, we're iterating over elements of a list. So uh, uh, I'm just going to do that here on these examples here. um, okay. So where am I? Where do I want to go with this? Yes, I want to explain that for loops are so common for iterating over elements of an array and a list that there's actually a an iteration structure that is designed specifically for that, and it's a bit easier and faster to write. Mm-hmm. Uh, okay. Okay, at this point in the series, I just explained how to create collections of data with lists and with arrays in C Sharp. And then I have explained how, because we very often need to go over all the elements of the array or the list to either populate them or to either read them and use them for whatever reason, then for loops are one of our best friends when it comes to iterating over all the elements of the array. And I also explained how from back in the old times of computer science, the letter I actually became the staple of the name for variables that we use in for loops because it referred to the index of the elements that we were looking for in an array. So this is just to say that for loops are so tightly tied to the idea of iterating over collections of data that at some point in more modern programming languages, people who were designing these languages decided that maybe we could actually like save ourselves a little bit of like the cumbersome typing that sometimes is involved in a for loop and design an iteration structure that is specifically designed for iterating over collections of data. And that's where the new iteration structure that we're going to learn today is coming, which is the for each loop. Okay? What that means is that a for each loop is a for loop. You think of it as a for loop that is specifically designed to make it very easy to write, going over all the elements one by one in an array or in a list. So let's say that I have this for loop that I'm using to print all the elements on the console, right? I can also iterate over all of these elements by using this structure called for each. I open and close parentheses, I open and close curly brackets, and then inside here of the parentheses, I'm going to specify a statement that is going to be useful to retrieve elements one by one from this list. So for example, if I have the list numbers and I know that each one of the elements of this list is an integer, what I can do is I can do on the fly, just for the for each loop, I can declare a variable of the type integer, so for example num, and I can say I'm going to declare this, and this is going to represent each one of the elements of my numbers list. So I'm going to define int num for each one of the elements in numbers. Okay? And then once I am inside of the for loop, then what I can do is I can print line this new variable that I have defined, which represents the first element in the number array, in the number list, the second element, the third element, each one of the elements one at a time. So I can do that, and if I do that, I'm going to print this here, and you can see that one at a time, I start printing each one of these elements to the console. Okay, so arguably, this for loop is a little easier to read. It's also sometimes a little faster to type. Um, and some people find it a bit more elegant. I honestly don't have a preference. I happen to use it quite often, actually, especially for lists. But it's definitely especially useful when, for whatever operation you're using, you don't really need the number of the position at which that element is. So for example, when you just want to read elements and when you know that you want to go over all of them, then it's particularly useful. This also works for arrays. So in the previous example, I'm going to cancel this and I'm going to say for elements, for arrays, I can also say for each integer number inside of numbers, can you please console write line this variable that I just created on the fly? And then if I run this code, I still get a printout of all those numbers in the array. Okay. Now, this is a bit more elegant. I find it a bit more. I actually like it a lot. Actually, this kind of, and it saves some cumbersome typing very often. Again, for each, a very interesting iteration structure. Whenever you're sure that you would just want to go over all the elements of a particular list or an array, and mostly for when you're not going to be changing them, where you're just going to be reading them or using it for some other purpose. Okay. All right. Wonderful. See you in the next video. Okay. What? Shivman is live? Where are you, Dan? Dan, where are you? Boo! No. Well, we are live too. You can see here. Is the coding train? No, but he's not live, right? Oh, he is live. Oh, Dan! Brother, what are you doing? Oh, I need to buy a whistle too. But it needs to be. Let me say hi. Hi there. I'm going to hack the. Hey Dan, how are you doing, sir? Good to see you. I love you, bro. Okay, let's stop. Let's not do this. All right. Okay. Thank you, Alka, for sticking around here. I appreciate that. Okay. So what is the last thing? I think I'm close to calling it today. Oh, objects. Do I want to talk about objects? Do I want to talk about objects? Yes, let's talk about objects. Why not? Let me first wrap up this. So, arrays of data. Yes, you can have conditional statements inside of a for each block. Yes, of course you can. Yeah. So, for example, here, you see, I'm only going to, if number is greater than 100, then print that to the console. Otherwise, don't print it, you know? And if I do that, only the numbers that are greater than 100 gets printed. You might have a typo or something like that, Andres. But yeah, you can add conditionals, no problem, inside for each blocks. Okay, so let me put some comments here. Iterating over the array to populate it with data. Iterate to print each element to the console. arrays can also be iterated with the for each loop. Okay. I'm going to keep this as the main one. And I'm also list can also be iterated with the for each loop. Okay, and then this is the, I'm going to hide this and I'm going to, okay, so I think we're good. Okay, and then oh no, so here, and this is going to be 33 classes and objects to the desktop, and read key. Okay. Okay. All right. So yeah, so this is, so I'm going to record a short video that is going to be an introduction to what classes and what objects are, how can I use them, and the idea of properties and methods. But I'm not going to get into the weeds of that because I want to, yes, I want to do a full section of object-oriented programming. It's going to take me some time. So I'm just going to show them as a way of discussing more complex data structures. So data structures that are, instead of containing just lists of information, they contain different things, depending on what and their quality. So I'm going to do that. And then after that, I'm just going to call it a day. I'm going to do some Q&A and some social for those of you who may have questions or want to talk about anything. And then I'm going to assemble my new desktop computer, which I'm very excited about. And I may actually end up sharing some images with you guys. Okay, so let's start. Person instructor new person list console write line instructor name console write line instructor age instructor say hi. Maybe this is a metaphor that I can use. Or I can say here instructor.age equals 21, of course, right? Okay. So maybe this is how I can make an example about that. Yeah, so maybe let me introduce this way, and then I talk about the particular example of console as a class that already exists, and math as a class that already exists. Um, and then I can just wait. It's like a gentle introduction. Um, yeah. Okay. Let's do this. Okay, at this point in this series, we have started to look at more complex data types, and the ones that we just saw in these videos were how to store sorted lists of the same elements one after the other, so collections of data, right? And that is great when what we want to store, what we want to represent is the same data type, but just like a numerical list or like a list of these elements one after the other. But it turns out that that is not enough to represent the richness of the data types that we can have in computer programming, because that is great when you want to store like a million numbers, but maybe there are other elements or other types of data that you want to store that cannot be fully described just as one number or one string or a list of numbers or a list of strings. Maybe there are more complex data types that actually, inside of them, in order to represent them properly, you need a bunch of numbers, but you also need a bunch of text, or you need a bunch of booleans, or you need like a lot of different things combined, right? This more complex, more rich data structures that incorporate different types of data and that also, in fact, incorporate functionality, these are typically referred to as classes and objects, and these are at the core of the most modern programming paradigms in computer programming, which is object-oriented programming. Okay, and I'm not going to get into fully describing that and making examples of that yet. I will have a full section down in this series, but I would like to make a gentle introduction to the notion of objects and the notion of classes, because it's really fundamental and we will be using them and learn how to work with them in these initial phases of the course. So one of the nice things about classes and objects is that what they typically do is that they represent some kind of metaphor. They are a data structure that represents some kind of metaphor about an idea that we want to represent numerically. And what do you mean with that? Well, as opposed to storing a list of numbers, which in itself is a metaphor. Just by using the word list, we have a very clear metaphor of like data sorted one after the other. If the metaphor, for example, was that I wanted to store something that represented human beings, then human beings have a lot of properties that must be represented with different data. For example, I have a name, which is a string. I also have an age that is an integer number. We typically don't say I am 30 something point something years old. You usually round that up, right? Or but my height, I probably want to use decimal values for that, right? So there has to be a way of doing that, and the code that I'm going to write right now is not going to work. It's just pseudo code. It's an idea for code. But just like I can declare variables of the type number, boolean, etc. I might be able at some point to create variables that are of a particular type that represents an idea. So for example, maybe at some point in the future, I will be able to create a variable called instructor that is of the type person or is of the type human. I don't know. And then maybe when I create that new human instructor, then I can, when I do that, I can create it by giving it some initial information. So for example, the name Jose Luis. All right. Again, this is pseudocode. It's not working. It's not really implemented, but it's just an idea. Okay. This human will probably have some properties. These properties are probably going to be something like, I don't know, maybe because I already started it with some data, then maybe what I can do is I can already print to the console the instructor dot the name property that it has, and we can think of this as a variable that lives inside of the human object, all right, of the instructor object, and then that contains the word Jose Luis. And probably this might print to the console the word Jose Luis. I don't know. It's just an idea. But even I could even add more data to this object. I could say instructor.age is going to be equal to 100 because you know this guy is like super old. Instructor.height is 5.9 more or less for those of you who have never met me in the real world. And instructor dot wears glasses sounds like it might be a Boolean value. So this is going to be true. All right. And I can store all these values inside of the instructor object. Okay. So we will very soon start working with a lot of these data types that are custom, okay, that are available as part of the C# vanilla system environment. But we will also be able very soon to create our own data types like this. And the idea is that I want you to think of classes and objects as complex entities that inside of them can hold other variables which will have their own types and that can store in their own information and that we can change and that we can read. For example, here I'm reading name and I'm printing it to the console, and here I am storing values for each one of these variables. And on top of that, they will also have functionality. So they will have functions, they will have actions that I can call for that particular object and that will yield particular actions in my program or will give me information. So for example, I might be able to say instructor dot say hi, and then this might print to the console, hi, I'm Jose Luis, you know? Maybe, if that's how the human class has been implemented. Okay? So, but don't really, this is just a teaser of what we will be looking at very soon and how we will be implementing this on our own. But some real world examples of classes and objects that we can already work with that we know that are available for us. This human example doesn't exist, but an example that already exists, for example, is the console object. All right, this class already, if I hit dot here, you can see that it has a lot of stuff. So for example, here it has the write line method. So this is a function that I can use to change something. So I can just write like hi here, and then this class will know what to do with this method that it has, right? Or for example, it also has like a bunch of properties like buffer height, buffer width, whether if the caps lock, you see this is a Boolean, whether if the caps lock is turned on or off, and it has like a lot of, the ones that are wrenches are properties, so those are variables that live inside of the class, and the ones that are purple boxes, those are methods. So those are functions that we can call to either get information or to perform some action. Same for, we have already seen that. Same for the math class. If I type math dot, you can see that this class also has a lot of methods, sine, cosine, square roots. So it has a lot of functions that I can use to calculate stuff. So for example, square root given a number double gives me back another number, returns a value, which is the square root of that number, right? So for example, the square root of 4 is something that I can store as a variable, okay? But stuff that I can also read from that object is, for example, the value of pi. So if I go to math dot, there is a variable inside of the math object called pi, which will give me as a double the ratio of the circumference, blah, blah, blah. Unfortunately, there's no tau, you know, so C# is probably not such a cool programming language after all. Does Python have tau? Huh? I probably doesn't have tau either, right? But again, this is a variable that lives inside, it's a property, it's a variable that lives inside of the math class and that I can always read and use to my advantage. So the bottom line or the takeaway that I want you from this video is that there are these other more complex data types called classes and objects, and I will explain actually what the difference between a class and an object is very soon. But there are these more complex data types that instead of storing one data type, or if instead of storing a list of data types, they can store multiple data types with names. So these are properties or like internal variables, and they can actually also store functionality. They can embed functionality. These are typically referred to as methods, but you can think of them as functions that live inside of that class. And then when we call them in that class, they perform a particular function related to that class. All right? How to understand this better and how to even create our own. We will have a full section with a bunch of videos on this topic because it's probably like the most important topic that you're going to learn in this whole course. So stay tuned for that, but I just wanted to give a gentle introduction. I felt it was good in the pace of the course, and so that when you start using these more complex objects, you start understanding a little bit of what's going on behind the hood. Okay? Wonderful. So thank you very much. See you in the next video. All right, it's time. Woo-hoo. Okay. Whoa, that was quite a recording session. Ugh. How is everyone doing? I'm very tired. I'm ready to start. Oh, you see the sun on the chroma? I am ready to start the weekend. Who wants to start the weekend? Hmm? Okay. All right. So I'm going to take a 1-minute bathroom break. I'll be right back, and then I can do some Q&A and some questions. I'll be right back, and some social. All right, I'm back. Any questions? Anything you would like to discuss? Um, any topics? Any difficulties from maybe from what we have seen today? What do you think was the most complicated part, or the one that you still have questions about, um, or what do you think was the most obvious thing, the most easy thing to relate? Can you let me know? What was the thing that was easier to understand, and what was the one that was a bit more complicated, perhaps? Arasto, seriously? Is that true? I'm so going to look this up right now because if it does, I may have to change. I may have to change my opinion uh, about uh, about Python. Damn it! It has Tau. Oh my god! Am I going to have to start liking Python now? Seriously? Oh my god! Seriously, Tau Day? Oh my god! No! Oh my God! Did I tell you? Have I told you guys about Tau Day and Tau Day celebrations? Oh no! Yeah, this was us. This was me and my friends celebrating Tau Day in 2015. Oh no, the pictures are not. Oh, yes. Yeah, because what do you do on Tau Day? You celebrate by eating two pies, right? Ah, yes. Tau Day celebrations. 2015. I actually let myself. You see this mustache, and this it's like a Tao stash, you know. Oh my God, I am so conflicted right now. What am I going to do? There's Tao in Python. Oh my God, my whole world is upside down. I don't know what to do now. Oh God. Okay, I'm gonna go home and cry. I don't have any choice. Who was this? Arasto. Arasto, you have ruined my weekend. You have ruined my weekend. I don't know. I'm just gonna, yeah. I'm gonna, I'm gonna spend the whole weekend crying, and I don't know what to do now. Push. I stand mind blown. Oh my God. Monique is, yeah, I need to change it. Monique is asking if I have followed presentations on Ikari. Unfortunately, I haven't really attended other presentations at Ikari because um, they were super early in the morning for my time frame, and because they were all in parallel, basically I attended one session, and that basically that was me basically one quarter. There were only four sessions, so that was a quarter of the conference, and the other sessions I had to wake up at 4 a.m. to watch the other sessions. So no, I have not followed other presentations, but I have the proceedings, and I tend to like skim them and take a look at what's the current research, etc. So I like that. But now, why do you ask, Monique? Um, and yeah, Arasto, I think I'm going to remove your moderator privileges. This was evil, what you just did to me. Uh... okay. All right. If there aren't any more questions, or if you're not interested, you don't have any other way of messing with my weekend, I think I'm gonna hang up and start crying right now. It was a pleasure. Um, but yeah, maybe this was the last video because now I don't know what to believe anymore. I don't know if to teach C sharp, to teach Python, to just teach pure math, to just like retire from my career of teaching. I don't know. I don't know. I don't know what to do. I'm going to call it a day. Thank you very much, everyone. We start learning Python. Really? Is that what's gonna happen? Am I going to have to start teaching Python? Oh my God. All right. It was a pleasure. It was a painful pleasure, Arasto. But anyway, thank you very much to everyone who stayed all day here with me, learning C sharp, which I thought it was a cool language, but I may have to rethink that. And have a good weekend. And I'll send you photos of my new machine as soon as I put it together. Okay? Thank you very much. Have a good one. Stay tuned for the videos. Subscribe, like, etc., etc. Bye bye. Boo, Arasto. No, you're not cool anymore, man. I'm not glad that you're part of this. You're. Bye 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 bye.